This is SpaceTime, Series 29, Episode 83, for broadcast on the 13th of July, 2026. Coming up on SpaceTime, planet Earth's earliest known asteroid impact site finally dated, a Chinese spacecraft has reached Earth's second moon, and seafloor spreading seen in action on a large scale for the first time. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have determined the most precise age yet for the oldest known impact crater on Earth, finding it to be some 3.024 billion years old. That makes it the only recognised impact crater from the Archean Eon, a time when the planet's earliest continents were still forming. The findings, reported in the journal Geology, provide new insights into how meteor strikes shaped the planet during its earliest history. The study's authors were investigating rock formations at North Pole Dome, a geological feature located in the Pilbara Craton some 1,600 kilometres north of Perth in the Western Australian outback. The structure covers an area of around 30 by 40 kilometres and features a raised central dome about 16 kilometres in diameter. Some initial estimates suggest the broader original crater would have spanned up to 100 kilometres wide. The study's lead author, Chris Kirkland from Curtin University, says the findings help resolve a long-standing question about the timing of the impact. Kirkland says while the site had previously been identified as an ancient impact structure, its exact age remained uncertain. But the impact left behind chemical clocks dating the minerals that were remade or newly grown in the damaged rocks. Key evidence came from zircons, tiny but extraordinarily resilient minerals that can keep geological time for billions of years. Some of the zircons at North Pole Dome have unusual branching skeletal shapes. Kirkland's interpreted these as impact-modified crystals formed when older zircons were disrupted, partly recrystallized, and in places regrown during intense heating caused by the impact. These zircon crystals recorded an event around 3.024 billion years ago, which the authors believe is the best time estimate for the impact. To confirm the results, Kirkland and colleagues analysed a second mineral, apatite, which formed as hot fluids moved through shock-damaged rocks. And this independent dating method produced the same result. The agreement between two different mineral dating systems provides strong evidence of a signature for a single major event, an asteroid-meteor impact. Ancient impact craters are incredibly difficult to date. It's because over billions of years, things like plate tectonics and water and wind erosion erases impact structures, and rocks can be altered by heat, pressure and fluids, which can obscure or reset the original impact signals. Kirkland says this discovery pushes Earth's impact record much deeper into geological time than any previously well-dated crater, offering a rare glimpse into the violent processes that shaped the early Earth.
We find these shatter cones in the rocks in the Pilbara. So shatter cones are these special features within rocks that are the real smoking gun for an impact. So these are like upside down conical features within the rocks. But there was a bit of an outstanding question, which was what were the age of the rocks and indeed the impact event that caused these shatter cones. So we managed to find some very delicate little features within the rocks themselves that created a new mineral, and that new mineral tells us about the intense heat of the impact, and that dates it to a staggering 3 billion years old. So it's now the oldest impact crater on the planet.
Now this evidence, these minerals were zircons. What is it about zircons that makes them so unique as geological timekeepers?
Yeah, the preeminent geological timekeeper, really, geologist's best friend. It's really because they form quite readily, but once they're formed, they stay in the rock record. So they form because they contain a little bit of zirconium, but they also, when they grow, incorporate a little bit of uranium. And over time, that uranium changes to lead, so it gives us this inbuilt stopwatch. Now, the neat thing about zircon is that while it's in the rock, it can change and recrystallize because of other processes, but it requires quite an extreme process to do that. So these zircons that were sitting about quite happily 3.5 billion years ago, which is the age of the original rock that was there, got whacked by a huge impact event, and that impact event brought with it a lot of energy and heat, and that heat recrystallized those zircon grains, and it changed them into these beautiful forms that look like little lightning bolts within the rock. And those little zircons that are now lightning bolts give us the 3 billion year old age. So it's a bit of detective work to piece that all together, but it gives us this really detailed history of the process that went on there.
And how do you go about actually dating a zircon crystal? What's the process?
Yeah, so it's a bit of laborious, painstaking work, but what you do is you take, in this case, we took a slice of the rock, literally a wafer of the rock. We cut it with a rock saw with a diamond blade, and then we were able to use a range of different microscopic tools, literally everything from a light microscope to scanning electron microscope, to really go in and hunt in detail for these little zircon crystals. So the crystals themselves are really small. They're about 20 microns across, so you could fit quite a lot of them on top of a human hair. They're that small. And then what we did is we took those slices of rock and put them inside an instrument, an Australian-built instrument, actually. It's called the SHRIMP, which stands for the Sensitive High-Resolution Ion Microprobe. And that allows us to fire ion beams at the sample surface. So we targeted the zircon, and we fired a beam of oxygen ions into that. Those ions ablated the surface or blasted the surface, and from that we were able to effectively count, using a glorified amplifier, the amount of uranium and lead ions that were coming off the surface. And because the ratio of uranium to lead is a clock, we were able to use that to calculate the age of the crystals. So it's really important that we use that beam-based technique to fire beams into the crystals, because we could find older crystals that were 3.5 billion years old that told us about the original age of the rock. That for a geologist is called the target rock. So we could work out the target rock age, but we could also find these lightning bolt like skeletal crystals, little skeletons of crystals, and they were the ones that are 3 billion years old that help us understand the age of the impact event.
And as well as the zircon, you're also able to find a second mineral which helped confirm the results.
Yeah, that's right. So we were also able to find apatite. So apatite is a calcium phosphate mineral, and it responds a little bit differently to zircon. So it also grows with a little bit of uranium. So because it's got a little bit of uranium, we can look at the uranium-lead ratio, and that gives us an age for it. But if we look at the chemistry of the apatite, it's interesting. It's enriched in its kind of mid-rare earth elements, and that's a very characteristic fingerprint for growth from hot water. So that's really interesting. So now we've got evidence for an event that brought an awful lot of heat at 3 billion years ago, and then an event roughly at about 3 billion years ago that also involved a lot of hot water circulating. And those two things put together in a rock that has shatter cones, a rock that's been subject to impact shock, tells us about an event that is the impact event itself at 3 billion years ago.
Now, usually when you're at a impact site and you fossick around, you can usually find little dark glassy balls on the surface, spheres on the surface. Were they around, or is this simply too old for those sort of things to still be there?
Oh, that's a lovely question, because it actually gives us an awful lot more information. So what you're talking about are called spherules, and they're, when an impact hits, they will throw up material from the surface, and it will rain down as glassy little balls, because you can imagine all the energy that came into the planet. Now, what's really interesting about this site in North Pole, probably about a decade ago in the Pilbara, there was actually, in the same part of the stratigraphy where we managed to find the shatter cones, there was evidence found of these glassy black balls, these spherules, and that was taken as evidence of an ancient impact. So the reason this is really interesting is the rock that contains the shatter cones also contains these little glass balls, these spherules. So it actually has to tell us about an even older impact event. So this rock that contains the North Pole crater that formed the shatter cones, even earlier in its history, must have been hit and incorporated these little glass balls. And that pieces together to tell us about the early Earth and then the impact history on the early Earth. So, we can go out and look at the moon on a cloudless night. The first thing we see is the impact craters on it. But Earth has remarkably few impact craters. So the nice thing that we're able to now start to piece together is that the earlier Earth matched probably, or was like the moon record. It was getting pummeled by impact craters. And it's just that on Earth, we've got erosion and plate tectonics that remove all that evidence.
And what is it about the North Pole Dome region that allowed the usual erosion of this evidence to be halted somewhat.
Yeah, that's right. It's just a really special place. But it's a really special place because of its age and also because it hasn't been cooked up and metamorphosed. So it's one of these really special places that is just been preserved. It's not really at high metamorphic grade. So in other words, it's not been subducted. It's not been heavily taken to depth. So it's pretty much always been floating around as this really old piece of Earth's surface. So there are other bits like this in Canada and other places in Western Australia, but they're very few and far between. So it's really this deep time archive of our planet, and it's why it's so special.
Okay, you've worked out a date. You pretty well know what it was. What happens next? Where does one go to now? Are you going to try and work out what type of meteorite it was? Are you going to try and work out what direction it came from? Is that even possible? Where to next?
Yeah, so I think, because it's such an old impact site, it's probably several kilometers underground, in that we've stripped off quite a bit of the surface above it, so it doesn't look like a crater. The land surface today there is, it's a beautiful bit of the outback. It's not an obvious crater unless you're a geologist walking over the ground and seeing the shatter cones. But I think one of the really interesting things about this site is it gives us an opportunity to understand what other processes, other chemical reactions happened in the crust at the same time as an impact came in. So we can see all these veins and all these other, what geologists would call hydrothermal processes. So processes related to hot water penetrating through the rocks and modifying the rocks and creating all these different chemical reactions. So I think that's really important to understand those reactions and how they developed within the rocks, because those are the sorts of reactions that might have been important for other things happening at around that time, including potentially modifying what early life we had on the planet.
Yeah, that's another thing often found at impact sites. The chemical processes that are going on, they act to encourage the development of life in those areas.
Yeah, exactly right. So I think, they essentially act like catalysts to help kickstart prebiotic chemical reactions. So you're right, a big impactor is bringing in huge amounts of energy. So that energy will create heat. Heat starts to percolate and move fluids about and kickstart chemical reactions. So you're really looking at, starting a cauldron and bubbling things away. And that's where you start to think about the development of prebiotic chemistry, and that might even lead to life. Now, what's interesting in the North Pole area is we know in the rock mass there, even older in the rock mass, so before 3 billion years, so before this impact happened, we know from stromatolites that there was already some form of early fossilized life there. So I think what we're getting is a better picture on our ancient planet. Our ancient planet was hit by not just one meteorite, but lots of meteorites, and those meteorites might have been important for early chemical reactions, and potentially those are the exact sorts of places that might have been the cauldrons for early life processes. So quite exciting.
What was that area? What was the North Pole Dome structure like 3 billion years ago?
It would have been a day 3 billion years ago when it got hit. But we know that our early planet was a water world, so there would have been a probably near global ocean with probably only little small bits of continental crust sticking up above that ocean. And the evidence for that is really quite easy to see in the rocks there. They're basalt flows, so dark coloured rocks, but they've got these beautiful shapes that are very pristinely preserved within them that are called pillow basalts. So they've got pillow-like shapes, and we can see the same sort of thing happening today on Hawaii, where you have a basaltic magma erupting underwater, and it forms these beautiful structures. So we know that it was a wet planet where the meteorite hit, and it struck that, and it would have vaporized a lot of water. That water would have condensed in the atmosphere, changing the atmospheric composition, but it would also have chucked up huge amounts of rock dust and as well. So there would have been a bit of a nuclear winter situation after that. But longer term processes, I think, are interesting to think about. And that's when we think about these long-term chemical reactions that would have been kick-started in the rock mass because of the immense energy brought into the planet.
You talk about immense energy. That can come from both speed and mass. Do you have any idea how big the impact was?
Yeah, that's a great question. That's actually quite challenging to get at. So I think that is one area that would be really interesting and important to look at. So to do those sorts of calculations, what you need to kind of do from the geological side is look at the extent of the impact damaged rocks, give you an idea of the size of the impactor. That's still work ongoing. Another interesting point is that we also don't really have any clue at what the impactor was. So that meteorite coming in, we don't really know anything about it. It was completely, obviously, vaporized. So trying to track down the chemistry of that is really challenging because there might be essentially nothing of it left.
That's Professor Chris Kirkland from Curtin University. And this is SpaceTime. Still to come, a Chinese spacecraft has just arrived at Earth's second moon, and the process of seafloor spreading seen in great detail for the first time. All that and more still to come on SpaceTime. China's Tianwen-2 spacecraft has arrived at a temporary second moon orbiting the Earth, although technically this object is actually a small near-Earth asteroid which is orbiting in sync with the Earth around the Sun. Called 469219 Kama-Awila, which means oscillating celestial object in Hawaiian, it also goes by the name of 2016 HO3, and it's one of 7 known so-called quasi-satellites which share Earth's orbital neighbourhood. Discovered in 2016, the asteroid's between 40 and 100 metres wide, making it the smallest asteroid ever visited. Many scientists think it could be a missing piece of the Moon blasted off during a major asteroid impact long ago. However, more recent analyses suggest it may simply be a common type of stony asteroid known as an LL chondrite, whose surface has been severely weathered by the harsh space environment. Long-term orbital analyses suggest that Kama-Awila entered its current quasi-satellite orbit around 100 years ago. The Chinese mission will spend the next 9 months orbiting this intriguing asteroid, studying and mapping its surface features, the asteroid's motion through space, the way it rotates and spins, and its composition. Tianwen-2 will also be looking for a place to touch down and collect around 100 grams of regolith for sample return to Earth. The Tianwen-2 mission launched from the Xichang Satellite Launch Center back in May last year. The name Tianwen means heavenly questions in Mandarin. The Tianwen-2 mission carries both a touch-and-go sampling system and an anchor and attach mechanism equipped with drills for collecting surface material. It'll depart the asteroid next April before releasing a return capsule that should land back on Earth in November 2027. Following its visit to Kama-Awila, Tianwen-2 will use a gravity assist maneuver to slingshot itself to the comet 311P Pan-STARRS, arriving there in January 2035. Tianwen-2's predecessor, Tianwen-1, is a Mars orbiter, lander and rover mission that successfully touched down on the red planet back in May 2021, releasing its Huron rover to study the planet's surface. The next mission, Tianwen-3, is slated for launch in 2028, and right now it looks like becoming the first ever sample return mission to Mars, bringing back red planet regolith to Earth in 2031. Meanwhile, Tianwen-4 will launch in 2030 as a pair of spacecraft, with one bound for Jupiter where it will orbit the moon Callisto, and the other heading for a flyby of the planet Uranus. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, seafloor spreading seen in detail for the first time, and later in the science report, development of a new vaccine which has the potential to protect people from developing AIDS. All that and more still to come on SpaceTime. Scientists studying a seafloor site southwest of Australia have for the first time actually captured how molten rock emerges at boundaries between the Earth's tectonic plates. A report in the journal Nature claims researchers set up instruments monitoring seismic activity and seafloor changes around 2 kilometres underwater along a 2.5 kilometre long stretch of the southeast Indian Ridge, which is the boundary between the Australian and Antarctic plates. The mid-ocean ridges are submarine networks of tectonic boundaries where new oceanic crust is formed from cooling magma and added to the seafloor. While 2/3 of the Earth's surface has been created by these ridges, little is actually known about how they behave during discrete spreading events. 2 months into their study, the authors measured earthquake activity and the ocean floor sinking by about 4.2 metres as millions of cubic metres of magma that had been stored underneath poured out to form new seafloor. They suggest this deformation was due to the deflation of a 2.5 kilometre wide magma reservoir located some 3.6 kilometres below the crust. The event released upwards of 160 million cubic metres of lava onto the seafloor. The seafloor movement peaked directly after the earthquake event at 5 centimetres per minute, before slowing to 1.2 centimetres per day 7 days later. The authors say there must have been decades of strain built up at the plate boundaries until the ground and magma movement finally released it in a seafloor spreading event. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Researchers have developed a new vaccine with the potential to protect people from developing HIV/AIDS. The findings, reported in the journal Nature, show that this new drug is the first to generate a high number of broadly neutralizing virus-fighting antibodies. The new vaccine works by intervening in a process called B-cell maturation. B cells make antibodies, and like many immune cells, B cells have an early naive stage before they're ready to make antibodies. They start to mature once they get the signal that a pathogen, such as a virus, is trying to attack. They then identify pieces of the pathogen's molecular structure and start producing antibodies that can bind to that structure and halt infection. As they mature, B cells tweak their antibody production, refining antibody structures to bind to a pathogen in just the right, vulnerable places. But HIV's been hard to beat because it mutates very quickly, changes its shape when it infects human cells, and is wrapped in an ever-shifting cloud of sugar molecules, disguising itself from the immune system and not giving B cells the chance to develop effective antibodies. The newly developed broadly neutralizing antibodies were first discovered in blood samples from a small number of people living with HIV, and these unique antibodies could recognize key viral structures even if the rest of the virus mutates. The human immunodeficiency virus HIV attacks the immune system, causing acquired immunodeficiency syndrome or AIDS. AIDS allows opportunistic diseases, normally easily combated by the body, to take hold and eventually kill the patient. The World Health Organization says that since first being identified back in 1981, AIDS has killed more than 43 million people globally and has infected up to 113 million others, with 1.3 million new infections recorded annually. HIV is transmitted through bodily fluids. Currently, there is no cure, although it can be controlled using a combination of complex drug cocktails. A new study warns that losing even a small amount of sleep each night could be linked to weight gain. The findings, reported in the Journal of the Annals of Internal Medicine, analysed 2 previous studies which included some 95 adults over the age of 20 who normally got at least 7 hours sleep. They found that decreasing sleep by just an hour and a half each night was linked to increases in body weight, waist circumference, and heart and metabolic risks. The authors also noticed that people tend to be less active than usual when they've not had much sleep. That could also be a contributing factor to weight gain. Scientists say the algal bloom that polluted South Australian coastlines last year was the most toxic species of its kind ever studied. Findings, reported in the journal Nature Ecology and Evolution, followed last year's identification of the microalga Carenia cristata as the source of the neurotoxin. The research by scientists at the University of Technology Sydney shows that Carenia cristata is an order of magnitude more toxic than the next most toxic microalga ever studied. The devastating bloom lasted about 15 months, and it still hasn't completely disappeared from South Australian waters. It's been responsible for the death of millions of fish, mammals, birds, and marine invertebrates. China has test-fired a nuclear-capable missile across the Pacific Ocean just hours after Australia signed a new defence alliance with Fiji. The launch from a nuclear submarine in the South China Sea near Hainan Island splashed down between the Pacific islands of Tuvalu and Nauru. The test represents an escalation of Beijing's ongoing military expansion and was designed to send a clear warning to Australia, which is working to strengthen regional ties with Pacific Island nations in order to counter China's efforts to expand its military presence in the region. So what do we know about the missile? Well, it was a JL-3 submarine-launched ballistic missile. It features a solid-fueled rocket motor and has a range of around 10,000 kilometres. The JL-3 is MIRV-capable, but usually carries a single 3-megaton thermonuclear warhead. They're launched from modified Type 094 nuclear submarines, which are based at Henan Island in the South China Sea. Now, normally, Beijing keeps its nuclear submarine fleet close to home. But this signals a clear escalation designed to let Western nations know that China is willing to send its nuclear submarine fleet much further afield. The Pentagon estimates China's nuclear stockpile currently includes more than 600 warheads, but says that's predicted to climb to over 1,000 by 2030. What may well be Australia's most famous UFO sighting has just celebrated its 60th anniversary. The Westall High School UFO was seen by dozens of school kids and their teachers back in 1966. The skeptic's Tim Mendham says even more intriguing than the mass sighting was how authorities tried to cover it all up.
The 60th anniversary of this Westall sighting has just come around, so it got a bit of notice. The story goes that a young girl ran into a school at Westall, which is in southeast Melbourne, and this girl ran into the classroom saying, Sir, there's a flying saucer outside. So all the kids went, yay, and all go running out. A teacher sort of went out as well, and then a lot of the kids in other classes went running out, and various numbers they reckoned of kids being out there. They saw a craft going through the sky, going a bit up and down, big speeds, slow speeds, supposedly landing in a field nearby called the Grange, and then it took off again, and some kids ran across to the Grange, leaping over the fences, which they weren't supposed to do, and one of them, they came close, and some of them felt they were even burned by it. Pretty soon after, police turned up and military people turned up and were talking to the kids and taking them aside, saying, you didn't see anything, you've got to forget what you saw, don't tell anybody, blah, blah, blah. Supposedly said the same things to some of the teachers. And then the principal of the school said, do not talk about this to anybody, don't talk to the press, don't talk to anyone. Neither some kids talked to the press, and the press were there. Some photos that one of the teachers took disappeared mysteriously. A news story or news film that was taken by a local TV station disappeared when they tried to find it years later. The kids gather every so often, every few years, for a reunion, and they all sort of discuss what they saw. Now, interesting, the drawings that people did of this thing vary. Okay, some of them are quite round, some of them are saucer-shaped, some of them have windows, some of them don't. One person even said they saw 3, but most of them say they only saw 1. What happens is that the suggestions were, 1, it's a UFO. That was very exciting, but they don't have a lot of evidence for that. The other thing
it is a UFO because it's unidentified.
Well, yes, it is, but not how we normally interpret the word, right? Not a flying saucer, right? The other thing was that is balloons. Either a weather balloon or a specific balloon that was sort of sent up to do radiation testing. Don't forget that in those days there were radiation tests in Australia.
This is the highball, high-altitude balloon project.
And there was a weather balloon certainly sent up about the same time that morning from a place called Laverton, which is in the southwest of Melbourne, across the other side of the big bay that Melbourne is situated around. And it would have flown across to about Westall because the winds were coming from the westerly direction or southwesterly, and it would have been quite appropriate and quite reasonable to expect that it would blow over that way. Now, with variable winds, gusty winds, it would go up and down and all sorts of things. The highball testing is possibly even more possible, although we don't have a lot of details of the actual launches of such
That's the
balloons.
one I believe, by the way. That's what I think it was.
Yes, I tend to believe that too, actually, because it is more active and it certainly can zip up at a rapid rate when the wind catches.
And it would explain why the military got involved.
Absolutely. Yeah, there are also suggestions at times that there were sort of small planes buzzing this UFO, flying saucer. That's what the kids report. They saw planes, 5 planes. It's right near an airport, so there'd be planes taking off and down all the time. And if something said they saw something there, I'd be buzzing around it too. Finding records of this thing is difficult. That's one of the problem things. Yeah, the records are a bit incomplete. But yes, I would suggest that it's a balloon, weather balloon, or a highball thing, and that what they saw, it's silver, it's reflective. Distances are hard to gauge, although people say it came down in the Grange, which is not that far away in this paddock. The excitement of the times, there was a time of high flying saucer fever. It was a topic at the time. If someone walked into a class and said, I saw a flying saucer, everyone knows what they're talking about, and everyone gets very excited. And everyone's already primed to see a flying saucer. And this is the problem with the reunions and that sort of stuff, that they reinforce memories. And as we know, as we've looked at other studies...
Well, it's like the Mandela thing again, isn't it?
Yeah, reinforcing memories, saying I was there, saying this is what it looked like, all these sorts of things. Very convincing and convincingly told, but not necessarily true. It's a fascinating area to look at because it's 60 years ago, because it was mainly kids talking talking about it, because there is variation in the records, because some people have reacted very dismissively of it, because there's having trouble finding evidence to one way or the other. It is a difficult one. It's an interesting one, witnessed by hundreds of people, so it's sort of pretty famous. Had international
when
researchers
tell you don't believe your eyes, that grates people.
Yes, and justifiably so. I think, people do believe they saw something with their own eyes and that therefore it's real. Not necessarily, especially when you reinforce it with other people's memories, but something happened. What it was is the question. Will we ever know? You're probably never going to get there, but it's an interesting story.
That's the Skeptic's Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.